morning, students. In today's class, I'm starting with one example on the basis of SSS congruency rule and RHS congruency rule. Okay, so before starting with the example, I'm just drawing the figure for this example. So you can see the figure over here. Okay, now these three lines are passing through one point, and that is A. Then there is a point P over here, and this P point is equidistant from B and C. Also, they are PB is perpendicular to AB and PC is perpendicular to AC. Now, first of all, what is given, we will write that first. Now, before writing this, I'm just reading up. I'm reading the question first. So, question says that P is a point equidistant from two lines L and M intersecting a point A. Okay, you can see over here, P is a point equidistant from L and M, that means equidistant from B and C I have taken. Then you can see that intersecting at a point A. Intersecting a point A, then show that the line AP bisects the angle between them. So we have to show that AP bisects the angle between them. That means we have to prove that angle 1 is equals to angle 2. So I am just naming the angles. I have named it as angle 1 and this as angle 2. Now first, what is given to us? I am writing that first. So what is given? That is, you can see that PB is equals to PC is given to us. Okay, now what else is given? What else I have taken actually? I have just supposed, let PB be perpendicular to L and PC be perpendicular to M. You can see over here, I have taken PB perpendicular to L and PC perpendicular to line M. Okay, so I can say that angle 3 is equals to angle 4 is equals to 90 degree. Now, what we have to prove? So, you can see that we have to prove that angle 1 is equals to angle 2. Now, for proving that angle 1 is equals to angle 2, we have to go in triangle PBA and triangle PCA. Okay, PBA and PCA. So here you can see that PB is equals to PC because of given to us. Okay, you can see here PB is equals to PC, that was given to us. Then second thing, we can see that angle 3 is equals to angle 4 because of each 90 degree. As you can see over here, we have supposed it that PB perpendicular to L and PC perpendicular to M. Okay. Then, what else we can write? You can see over here that one side is there, right angle is there. So, what else is left? From here, you can have some hint that right angle is being proved equal. So, and one side is already we have proved equal. So, what else is left? You can see that hypotenuse of these two triangles are left. And hypotenuse, where hypotenuse will lie? So, you can see that PA is acting as a hypotenuse for PB, triangle PBA also, and PA is again acting as a hypotenuse for triangle PCA also. So, we can write that PA is equals to AP because of, or can just write PA is equals to PA because of common side. Because of common side. So by which property they will be equal? You can see that by RHS criteria, by RHS congruency rule, or by RHS criteria, we can say that triangle PBA is congruent to triangle PCA. Okay. You can see that angle 3 is equals to angle 4, that is equals to 90 degree. That means this is one right angle we are having. Then next is hypotenuse. Again hypotenuse are also equal for both the triangles. Then next is side. One side is equal in both the triangle. So that's why by RHS criteria, triangle PBA is congruent to triangle PCA. Now, after this we can write that by CPCT, angle 1 will be equals to angle 2. So this what we need to prove. I think in this example there is no doubt. You can write it side by side, students. Okay, after this, we are doing 2 questions that are left for exercise 7.3. So I am reading here question number 4 of exercise 7.3, and then after reading the questions, both the questions, then we have to draw the figure ourselves. So first I am doing here question number 4 of exercise 7.3. So here it is given to us that BE and CF are 2 equal altitudes of a triangle ABC. Using RHS congruency rule, here it is mentioned specially that we have to use RHS congruency rule. Prove that triangle ABC is an isosceles triangle. So here from the question we can make figure ourselves, that is BE and CF are 2 equal altitudes of triangle ABC. So I am drawing over here what it is given, BE and CF. BE and CF. So BE will be this side and CF will be this side. Okay, are 2 equal altitudes. That means they are making 90 degree angle over here, and also this is equals to this, means CF is equals to BE. So and then we have to prove that triangle ABC is an isosceles triangle. Okay, this we have to prove by RHS congruency rule. It is mentioned over here, and we will use here. Okay, what we will do, as we have to prove that triangle ABC is an isosceles triangle, then we have to prove that both the angles are equal, also both the sides are equal. We will prove both the things. Okay, so first I am writing what is given over here. So given is, you can see that CF is perpendicular to AB, then BE is perpendicular to AC. Okay, what else it is given? That BE is equals to CF. These 2 things are given. We can say that this concluded. Okay, this we will write afterwards. Okay, now after this what we have to prove, and if it is mentioned that we have to use RHS congruency rule, that means we have to prove it by that only. So I am writing here what we need to prove. So you can see here we have to prove is triangle ABC is an isosceles triangle. That is, we will prove that angle B is equals to angle C and AB is equals to AC. Then we are starting our solution. Okay, as we have to prove that angle B is equals to angle C and we have to use RHS, so that's why I am going directly in these two triangles. Although we can go in these two triangles and then we can prove it, but I am going in these two triangles, that is because if we go in these two triangles, then it will not be proved by RHS congruency rule. So for proving it by RHS congruency rule, we have to go in these two triangles. That is, in triangle BFC and triangle CEB. Okay, BFC and CEB. Now here you can see that as it is given to us that angle 1 is equals to angle 2 because of 90 degree each. So we will write it here that because it is given that CF is perpendicular to AB and BE is perpendicular to AC. So due to these two conditions, angle 1 is equals to angle 2 is equals to 90 degree. Now what else we have to prove? Right angle we have proved. Then next thing is H, that is hypotenuse. Now for these two, hypotenuse is BC only. So we can write that BC is equals to BC because of common sides. Because of common sides. Then next is side. That means we have to prove sides. So for sides, we will go, we can take CF and BE as these two are equal to each other. So we can write BE is equals to CF because of given. So by which property? They are congruent by RHS. That means right angle, hypotenuse and side criteria. Triangle BFC is congruent to triangle CEB. Is this clear to all of you? Yes. So you can write it side by side. Now after this we can prove that angle B is equals to angle C. We have to prove this because till here question is not completed yet. We have to prove that triangle ABC is an isosceles triangle. Now after this, I'm just proving it, I'm just writing it on the top. Okay. So after this, we can write that as two triangles are congruent. So we can say that angle B is equals to angle C. That means angle ABC, I'm writing over here, angle ABC is equals to angle ACB because of CPCT, they are equal. Okay. Now, as both angles are equal, so what we can say? This implies that AC is equals to AB because sides, okay, this theorem first time we are using, sides equal to equal angles are equal. Okay. So, by this theorem, AC is equals to AB. Now, after this, what we can say? That triangle, this implies that triangle ABC is an isosceles triangle. Okay, I think till here there is. We will be doing next question of exercise 7.3. Okay, now we are doing question number 5. Again, first I am reading the question. So question says that ABC is an isosceles triangle with AB is equals to AC. Draw AP perpendicular to BC to show that angle B is equals to angle C. So that means a triangle is given to us and named it as ABC. This is an isosceles triangle. That means with AB is equals to AC. Now we have to draw AP perpendicular to BC. Then we have to show that this angle is equals to this angle. Okay, so I am naming these two angles. Okay, I am not naming it. It is very much clear to us. Now, first of all, I am writing what is given to us. So, given is that AB is equals to AC. Then, AB is equals to AC. Then, what else is given? That AP is perpendicular to BC. Now, we have to prove that angle B is equals to angle C. So, it is very much clear from the figure that we will go in triangle APB and triangle APC. Okay. Then, after going in both the triangles, what we will see here that AB is equals to AC as it is given to us. The next step we can write that angle 1 is equals to angle 2 is equals to 90 degree because of AP perpendicular to BC. Again it is given to us. The next point is we can write AP is equals to AP because of common sides. Because of common sides. Yes. So by which property they are congruent? As you can see that right angle is here, hypotenuse is here and one side is here. And similarly in this triangle, this right angle is equal to this right angle. This hypotenuse is equal to this hypotenuse and this side is equal to this side. So we can write that by RHS criteria, we can say that triangle APB is congruent to triangle APC. Yes or no? Okay. Now, after this, we can directly apply CPCT. So, by CPCT, we can say that angle B is equals to angle C. This is what we need to prove. Now, although this chapter is completed because in our this year's syllabus, we have to do till only exercise 7.3. But for inequalities topic, that means for next exercise, I am telling you some theorems, only results of those theorems, so that as these are helpful in further classes and so that you can learn that what these results says. So, you have to only see the result for inequalities of a triangle. So, there are 3 theorems for inequalities of a triangle. So, I am just telling you the results that what these theorems actually says so that you can apply it in your further classes if it is required anywhere. Now, I am starting with, so we are starting with theorems on theorems on inequalities in a triangle. So our first theorem is, that is according to the book theorem, it is theorem number 7.6. So that is that if two sides okay, of a triangle are unequal, okay, then the angle opposite to longer side is larger or greater. Okay, so this we have to prove. Okay, we are doing just result for this. So I'm just drawing a triangle over here, named it as ABC. So I'm writing here that in triangle ABC, you can see that it is given that if two sides of a triangle are unequal, that means if I take this as 5 centimeter and this as 6 centimeter, okay, then the angle opposite to longer side is larger. That means angle opposite to longer side is larger. That you can see that AC is longer. AC is longer than AB. So that means we can say that B is larger than C, because B is opposite to AC and C is opposite to AB. So I can write that in triangle ABC as AC is greater than AB. So what it implies? It implies that angle B is greater than angle C. Okay. So this what theorem says, that if two sides are unequal, then angle opposite to longer side is larger. So that means this is the result for this theorem. Students, you have to write it side by side. You have to write only the result and the statement for the theorem. Then come to next theorem, that is in any triangle, the side opposite to the larger or greater angle is longer. Okay. Now you can see that this theorem is opposite to previous theorem. That means this can be the converse for theorem number 7.6. Again, I am drawing a triangle over here. That is, I have named it as PQR. Okay, as it is given that in any triangle, the side opposite to the larger angle. That means angles are given to us. So we are taking here as 50 degree and 70 degree. If suppose it is given to us that this is 50 and this is 70, then what we can say? That in triangle PQR, as angle R is greater than angle Q. So what this implies? This implies that as PQ is opposite to angle R and PR is opposite to angle Q. So I can write that PQ is greater than PR. Okay. So this is what this theorem says. So these are the two theorems which are converse to each other and which are important one. So you have to write these and then you have to write the result. Then come to last theorem for this chapter. So I'm erasing this one now. This one is again important one, that is theorem 7.8, that says that the sum of any two sides of a triangle is greater than the third side. Okay. Now you can see here that theorem says that the sum of any two sides of a triangle is greater than the third side. That means in a triangle it is only possible, we can draw a triangle only if two of its sides, sum of two of its sides is greater than the third side. Then only we can draw the triangle. It is possible to draw a triangle. If it is not there, then a triangle cannot be formed. So it says that this theorem says that sum of any two sides AB plus AC is greater than BC. That means sum of any two sides will be greater than the third side. Only this is not enough. We have to prove three of the conditions for this theorem. That means it should be there that AB plus BC is must be greater than AC. Then third thing is AC plus BC must be greater than AB. These three conditions we need to, these three conditions are must to be there for a triangle to be drawn. So this what this theorem says. Okay. So these are the three theorems for inequalities in a triangle. So these are the important one. You have to revise it, and if there is any doubt in these theorems, then you can take it after this lecture. Now, after this, we are starting the revision part. Okay. So what you have to do, what is the homework for today? That you have to revise chapter number 7. Okay. If there is any doubt, then you can take it. I'm starting it with chapter number 7, so that's why you have to revise chapter number 7. If there is any doubt, then you can take it and I will just explain your doubts in my next lecture. So till then, you have to revise this. Thank you.